Our planet, when viewed from the vast emptiness of space, is a breathtaking sphere of brilliant blue and swirling white clouds. It is a world of water. Yet for all its apparent abundance, the water we can actually drink is incredibly rare. Most of the Earth's water is salty, locked away in the great oceans. Only a tiny fraction, less than 3%, is fresh. This precious fresh water is the lifeblood of our continents, nurturing the forests, quenching the thirst of countless species, and allowing human civilizations to flourish. It is the single most important resource for all life on land. However, our world is facing a growing crisis. As the human population continues to expand, our demand for fresh water has skyrocketed. We use it for drinking, for growing our food, and for powering our industries. In many parts of the globe, from sprawling cities to remote villages, clean, reliable water is becoming harder and harder to find. Rivers are running dry, lakes are shrinking, and underground aquifers are being depleted faster than they can be replenished by rain. This scarcity is not just an inconvenience, it is a profound threat to our collective future, creating hardship and conflict. The challenge of securing enough fresh water for everyone is one of the greatest tests humanity will face in this century. We have built dams, dug wells, and even developed technologies to turn salty seawater into fresh drinking water, a process known as desalination. While these efforts are vital, they often come with high costs and significant environmental impacts. The search for new, sustainable sources of fresh water is a constant and urgent endeavor, pushing scientists and engineers to look in places we have never looked before, to explore the hidden corners of our own planet. This relentless search has led to one of the most astonishing discoveries of our time. The story of this discovery begins not with a grand expedition but with something far more routine: scientific surveys of the ocean floor. For years, companies searching for offshore oil and gas have drilled into the seabed. Occasionally, their drills would unexpectedly hit pockets of fresh water instead of the oil they sought. These were often dismissed as small, isolated anomalies, curious footnotes in geological reports. For a long time, no one suspected that these scattered pockets might be connected, part of something much, much larger. It was a puzzle with missing pieces, scattered across the vast, dark expanse of the seafloor. The breakthrough came when a team of dedicated scientists from Columbia University and the Woods Hole Oceanographic Institution decided to investigate these strange occurrences more systematically. They suspected that these freshwater pockets were not random at all. Their hypothesis was bold. Perhaps these were not isolated pools, but signs of a massive, continuous aquifer system stretching for miles beneath the ocean. To test this idea, they needed a way to see beneath the seabed without drilling hundreds of holes, a task that would be both impractical and enormously expensive. They needed a new way of looking. Their chosen tool was a marvel of modern technology. It was a method called marine electromagnetic imaging. The team towed a specially designed instrument along the surface of the ocean. This device sent gentle electromagnetic pulses down through the water and into the seabed below. It then measured the way these signals were reflected back. The principle is quite simple but ingenious. Salt water is very good at conducting electricity, while fresh water is a poor conductor. By analyzing the returning signals, the scientists could map out the electrical resistance of the rock and sediment beneath them. The results that came back were nothing short of spectacular. The data painted a picture that exceeded even the scientists' most optimistic predictions. The areas of low conductivity, the signature of fresh water, were not small and isolated. Instead, they formed a vast, continuous layer. It was as if they had discovered a hidden river system or a massive underground lake sealed beneath the salty ocean. This was not just a scientific curiosity, it was a discovery of immense scale and potential significance, a new chapter in our planet's hydrological story. The scattered puzzle pieces had finally been assembled into a breathtaking whole. The sheer scale of this underwater freshwater reserve is difficult to comprehend. The surveys revealed that it stretches for at least 50 miles off the coast of the northeastern United States from Massachusetts to New Jersey. It is a continuous body of water trapped in the porous sediments of the continental shelf. Imagine a layer of freshwater starting near the shoreline and extending far out to sea, hidden beneath hundreds of feet of ocean and then hundreds more feet of rock and sand. It is an aquifer of monumental proportions, a hidden world of water lying just beyond our shores. To put its size into perspective, the scientists estimate that this single reservoir contains at least 2,800 cubic kilometers of low-salinity water. That is enough water to fill more than 1 billion Olympic-sized swimming pools. It is comparable in volume to some of the largest freshwater lakes on the surface of our planet, like Lake Ontario. Yet, this entire volume of water has remained completely hidden from humanity until now. It is a profound reminder of how much we still have to learn about the intricate systems that operate beneath the surface of our world, in the deep and silent darkness. So how did this fresh water get there? The current scientific theory is that this water is a remnant of the last ice age. Around 15,000 to 20,000 years ago, vast ice sheets covered much of North America. As these massive glaciers melted, they released enormous quantities of fresh water. Some of this water flowed into rivers and out to sea, but it appears a significant amount became trapped in sediments on the continental shelf, which was exposed land at the time when sea levels were much lower. This ancient water was then sealed in by layers of finer, less permeable sediment, preserving it for millennia. What makes this discovery truly special is the realization that this may not be a unique phenomenon. The geological conditions that created this massive aquifer off the American coast exist in many other parts of the world. Similar continental shelves can be found off the coasts of Australia, China, and South America, to name just a few. It is therefore highly probable that other enormous freshwater reserves are waiting to be found beneath the world's oceans. This single discovery could be the key that unlocks a new and previously unimagined source of water for humanity. The potential implications of this discovery are truly transformative. For coastal cities and regions facing severe water shortages, this hidden resource could be a lifeline. Tapping into these offshore aquifers could provide a new and abundant source of fresh water for drinking, agriculture, and industry. It could alleviate the pressure on overstressed rivers and inland aquifers, allowing them to recover. In a world where droughts are becoming more frequent and severe due to climate change, having such a vast, untapped reserve could provide a crucial buffer, enhancing our resilience in the face of an uncertain future. However, accessing this water presents a formidable set of challenges. The technology to drill through the seabed and pump the water ashore exists, thanks to the offshore oil and gas industry. But it is expensive and has never been done on this scale for water extraction. We must proceed with great caution. Any large-scale extraction could have unintended consequences for the delicate marine ecosystems on the ocean floor. There is also the risk of saltwater intrusion, where pumping out too much freshwater could cause the surrounding saltwater to seep in and contaminate the entire aquifer, destroying the resource forever. Careful management and further scientific study will be absolutely essential. Before we can even consider using this water, we need to understand the system much better. We need to know how fast the aquifer might be replenished, if at all, and what the environmental impacts of extraction would be. This is not a resource to be exploited recklessly, but a precious inheritance that must be managed with wisdom and foresight for future generations. The challenge is not just technological but also ethical, requiring international cooperation and a commitment to sustainability. Ultimately, the discovery of this hidden ocean of fresh water is a powerful story of hope. It demonstrates the remarkable ability of science and human ingenuity to uncover new possibilities and provide solutions to some of our planet's most pressing problems. It reminds us that our world is still full of secrets and wonders, and that by continuing to explore with curiosity and respect, we can find new ways to live in better harmony with our environment. The path forward will be complex, but this astonishing find gives us a reason to be optimistic about our shared future, a future that may, in part, be written in the ancient water hidden beneath our seas.